Good afternoon and welcome to the 23rd annual exhibit of hydrogen and fuel cell technologies. We've been here for quite some time discussing how these technologies work, where they can be applied, and how wonderful they are. Have you ever wondered, though, how safe they are by comparison with conventional batteries, for example? Just what do these technologies do? How do they compare with all the stuff you've got in your pocket? Every one of you has a phone, I bet. These are among the issues that people face when they develop and implement these technologies. And of course, the technologies themselves have to self-monitor. So there are sensors, for example. They're sensitive things and they have sensors. So we're going to be talking to about a specialist in this field. He's Nathan Cooley, who's Director of Commercial Sales at fuelcellmaterials, and it's all about the total cost of ownership of fuel cell sensors in fuel cell applications. Please welcome with me Nathan Cooley.
Hi there.
Hello, Nathan.
Hi, thank you.
So before we move too quickly into the fascinating ups and downs of our market, let's talk about fuel cell materials. It's a company. Where did it come from? How did it develop? And who do you work with?
Sure thing. So fuel cell materials is actually part of a larger company called Nexceris. Nexceris was formed in 1994 by two individuals, Bill Dawson and Scott Swartz, focusing on contract R&D with a specialty in ceramics and catalyst. Over the years, we've developed new technologies in fuel cells, catalyst, sensing devices, and created commercial products. And that's where we get fuel cell materials. And we also get our other brand, NTM Sensors. Fuel cell materials focuses predominantly on solid oxide fuel cell materials, components, test fixtures, basically everything a university, national lab, manufacturer needs to get started. We've got about 700 customers in over 70 countries, which, maybe 50 years ago would be pretty difficult for a company of our size. But now with the information age and being on the internet, we can really expand. Mm-hmm. And then finally, our NTM sensor brand, we took a lot of the catalyst and ceramic knowledge that we gained and applied that to gas sensing devices. We saw an opportunity there and felt like we could actually provide value to fuel cells, batteries, hydrogen, you name it.
It's a seize the day philosophy, of course, which is always the way to go in business. We'll get to the notion of, for instance, it's a growth industry, so you're hiring. We'll have to mention that again for those who are looking for jobs. But there is first of all, before we get to the sensors, which is the focus of our talk, let's talk about the products. You have, as you mentioned, a certain selection of products that you provide. Could you run through them for us?
Sure thing. So I think that gets back to the fuel cell materials brand. Over the years, we just developed these materials ourselves, and then we started talking to other people in the industry and realized that these could have a real value to people. There's all kinds of researchers out there trying to get started, and they're working on one single component of the fuel cell, and they need a ready supply of everything else. So that includes raw material powders, finished good powders, mixed catalyst, sensors, components, complete cells, half cells, test equipment, you name it. Basically, that's what we created fuel cell materials for. It's a place where a university, national lab customer can go, and they can get everything they need to get moving.
So there are many types of sensors, and there are specific sensors that can be used for various cells. I find what is so interesting about your sensors is it is directly related to safety, among other things. First of all, why are the sensors so important that you manufacture? What do they do?
Sure thing. So our sensor is a low flammability limit hydrogen sensor, meaning that it works from 0 to 4% hydrogen. We feel like that is the most important place to operate for a safety sensor, because after you get to 4% hydrogen in air, you could be in a very dangerous situation. That's where things can light off. We know that hydrogen's a pretty light gas, but it can still accumulate and cause serious damage.
So this is it's a canary in the coal mine.
Yes.
But one that fits in the box and stays close to the unit. You mentioned the flammability limit. I have to always add, in this industry, we're very sensitive about people mentioning fire or flammability in close proximity to the word hydrogen. But you mentioned the flammability limit of 4%. Just so we don't scare everyone off, if you had to compare the flammability characteristics of hydrogen with natural gas, because that's often where the phobias occur, which is more flammable?
Oh, the natural gas for sure. I mean, I don't even think it's close. I mean, if you look back at, I'm going to give credit to Graham Cooley, no relation. Earlier this week, he was talking about how many hydrogen events there have been in our industry, and the only one that someone could name was the Hindenburg, which was 80 plus years ago. And if you think to what's happened, we've had a great track record for safety, and a lot of that's because of the engineering, the systems we've put in place, and also the gas sensing devices we've had. So, we've done a great job being inherently safe with our industry, but I still think we're at the infancy, even though we've been here for, what did you say, the Hannover Messe and the hydrogen?
23 years for the Hannover Messe.
We're still moving forward. We're still trying to get to commercialization, and it'd be very detrimental to our industry if we had one of those hydrogen events. I know there's other industries that we can talk about, batteries, things of that nature, where we're willing to accept those issues. So,
this is a fascinating issue. We can't afford a Fukushima in the industry for a number of reasons. We don't. We need the volume. It's also a question of acceptability. Sure, there are some applications for which conventional batteries are okay, but safety is somehow unfairly measured.
I agree. If you can think about some of the things that have happened with lithium-ion batteries over the last 5 years. You've had the 787 Dreamliner incident that the planes that grounded the entire Boeing fleet of that new product because of a lithium-ion battery issue. And then that was quickly forgotten. Same thing with maybe a prominent cell phone manufacturer.
Whose name we will not mention.
Causing $3 to $5 billion in recall. Yeah. But people, I imagine, like you said earlier, everybody here probably still has a cell phone in their pocket, and it's using a lithium-ion battery. So we've learned to accept that. But again, that's something I don't think we can do with the fuel cell and hydrogen market.
And these are important things because we all know that fuel cells sometimes have a relatively high entry price, but durability, long-term function, reliability is very important. And if you have a plane, you can choose to put a fuel cell in the plane. And here again, it's the notion of acceptability. It is the conventional batteries that have proven less reliable, more dangerous. If you have that mobile phone that just happens to explode in your pocket, it's a danger. They usually do it, of course, while charging. But
but actually, a couple weeks ago, there was a woman flying from Melbourne to Beijing, and her earbuds exploded.
I shouldn't.
Yes.
Sorry. Yeah. So she heard the music, as we say.
I guess so. Yeah.
So
quite a bang at the end of that song.
Yeah. Okay. So the conventional batteries, as opposed to the modern technology, we have an acceptance issue, and the unfair measuring stick is. Interesting. When we get to sensors, though, and this sensor is particularly related to safety, there's going to be, of course, a question of, because there are other sensor manufacturers who do specifically this. What is key? What is interesting about your sensors? What gives it the cutting edge by comparison with other sensors that measure hydrogen?
Yeah, so there's plenty of sensors on the market. I think as our market matures, we're bringing more competition and free market to the industry, which can only help us launch products. Mm-hmm. But what we've looked at is the hydrogen sensor. All the people that we're talking to, all our partners, they have to have reliability. That they're entrusting us to provide a product that they can use to be safer. And if they can't rely on it, then what's the point of even having it? it has no use. They're also really concerned with upfront cost. And honestly, what I want to speak most about today is that there's so many things outside of upfront cost that we need to think about, that with calibration, reliability, premature failure of the sensor, all those things add to the cost of a sensor. And with only thinking about the front end, you're kind of short-sighting yourself. And you're kind of thinking more about launching a product than having a product in the market. Where when you have a product in the market, you're thinking about supply chain. You're thinking about how your upfront and downstream costs affect your ability to be profitable. Because ultimately, at the end of the day, I think that's what most of the companies here are trying to do. We're trying to solve world problems, but we're trying to at least create jobs and be profitable. So that's kind of what we've been trying to do with our hydrogen sensor and how the philosophy we take when we talk to customers.
And of course, because the initial cost of hydrogen fuel cells it's not small. Durability, functionality, and sometimes even energy density make them a big winner. You can put them in cars and drive quite a ways. But the initial cost is not small. Do you get a little bit frustrated that people don't get the message that investing a little more for a sensor that does not require for example, calibration,
Sure.
That has immense durability, it's simply a wise investment that saves the risks you could have to that fuel cell, or to that system, I should say.
Exactly. Speaking back to what we were talking about with the battery failures and the Hindenburg and things of that nature, if you make this small investment in a sensor, you can think about, it's not hard to think about what kind of impact it could have if you didn't have a sensor in place. As I said, I don't know if our industry can survive a massive event like we've seen with the lithium-ion batteries. So at the very least, if there was to be a hydrogen event, catastrophic event in our industry, it would hurt branding, it would hurt that product, it could sink companies, it could, at the very least, it would set our industry back years. So, go ahead.
I'm just thinking the fairness issue. Everyone's working on those cars that drive themselves. And they've already accepted a few collisions with fatal casualties. We can't afford that on an industry, and it really is an important point. I should add that we do have time for a question or two if you are interested in asking a question about fuel cell sensors and safety and costs and applications that are concerned. Just raise your hand and we'll attempt to address it. I'm interested, of course, these are important considerations. I find it interesting because you are the first person who's brought me to reflect upon the notion of acceptance of technology and the unfairness of the way we think of safety, because it's not an issue that hydrogen has. It's just got this historical event.
Yeah,
But
I don't know why we keep talking about it. We live in an age where we're so focused on the next thing and instantaneous results, but for some reason we think back to 80-year-old events to dictate where our market goes forward.
But you, of course, you have a mission here at the Hanover Fair, and I think it goes in two directions. One of them is, here you have a technology. The technology is versatile. It can be placed inside a number of alternative ways of constructing fuel cell systems or whatever. So are you interested in partnering with people who are working in the R&D level right up to commercial products? Are you looking for people to implement and work with?
Yes, actually, we're looking to partner with just about anyone here. What our goal here is to help make sure that companies, universities, national labs, everybody in the industry understands the importance of sensors, but two, just how best to implement them, and third, what the total cost could be. So we work with a lot of our partners to truly understand what those costs are, find unique ways of doing supply chain and supply agreements to bring the sensor to them while also limiting inventory carry and cash flow problems. Because a lot of the companies here are still trying to drive cost out and become profitable at some point, and having cash flow and having to take a large inventory of a product that you're not using as often is kind of difficult. So focusing there has been very important for us. We're also working to create in-field calibration sensors. As we were talking earlier about the cost of calibration, the cost of premature failure, we want to drive that away, get rid of that, allow you to do calibration. That gets rid of, again, inventory costs of having to maintain a secondary supply of sensors for when you have to go do calibration, gets rid of unforeseen service calls to your customer. The last thing we want our customers to do is to have to go fix problems that we create or that a sensor creates for their customer. So all those things we're trying to do with our partners now, and we're always looking to find more. If anyone would like to stop by our booth, I think it's C40-1. Right over there. We'd be more than willing to talk to you about what your sensor needs may be, help you understand the total cost of ownership, and then point you in the right direction. That may be with us, but as you said, there's lots of sensor suppliers on the market now. If we're not a great fit for you, we're going to tell you that, and we're going to try to help you out.
And of course, engineers will swear, calibration, I know I have to do it. But if you go around and look at engineers and the way they drive their cars, they're not going to remember to check the pressure of their tires before every long-distance voyage. Yeah, the best thing is to have a reliable product that does certain things for you. So,
exactly.
Yeah, it's been a pleasure talking to you. I've been talking to Nathan Cooley, who's Director of Commercial Sales at Fuel Cell Materials. I hope you have great success here. I hope people know it's a growth industry, so he's interested also in young engineers right up to
always
the manufacturers. And I hope we'll see you back here next year with a new success story and more issues on safety to talk about.
No problem. We've got plenty of brands, so maybe next year we'll focus more on fuel cell materials.
Wonderful. Okay, Nathan, thank you very much for being here.
Thank you.
And thank you. We'll be continuing in about 45 seconds with Dr. Joseph Callow. He's at Deutsche Luft- und Raumfahrt, and they'll be talking about fuel cell and hybrid systems for aviation. We're flying.